Hello, this is Olivier Valois speaking. I'm from HPE, looking after HPE SmartIO, also based on Pensando. This is a next generation networking card with lots of hardware acceleration capabilities. For Pensando, this is very much focusing on networking and security features. And in this demonstration, I would like to show you how easy it is to configure encryption between VMs, for instance, hosted in ESX servers. So you can see my screen. That's the Pensando console from where you can configure and manage all the networking cards. So this is really a pure software-defined networking solution. With networking cards installed in different servers and Pensando console managing these cards remotely. So let's focus on encryption first. Encryption is in the security menu. It's IPsec policy. There is one right now configured, which basically is going to encrypt ICMP traffic. You can see it here, ICMP, between IP address 73 and 72, or 73 and 71. What are these IP addresses? These are VMs, which, so 73 here, it's hosted on host 21, 71 on host 21 as well, so it's in the same ESX, and 72 is in another ESX. Okay, so let's verify first that I can ping between 73 and 72. So this guy here, it's 73. So let's ping 72. Good news, it works. So now this traffic is supposed to be encrypted. I'm mirroring the traffic, disable the false. I'm mirroring the traffic before encryption. So what does that mean? That means that I'm taking the traffic and copying to my Wireshark server 10.6.48.60 before it is actually encrypted by the card. And so if I'm going on my Wireshark, let's start my Wireshark. Let's filter on based on ICMP. And we see my ping between 73 and 72. So now let's verify if I can see my ESP traffic. So my traffic, which is encrypted, I can't see it. So now let's change the mirroring rule. So I will enable the rule that is called after encryption. So first I will disable this one and enable the other one, which is called after encryption. Here it is. So the difference between the two is one is basically taking the packets before it is encrypted, and the other one is taking packets on the uplink. So now it's operational. Let's verify on ESP, and yeah, we can see ESP traffic between 73 and 72. That corresponds to the ping. By the way, if I check my ping, okay. So now let's verify what's going on if I remove the encryption. So to do that, I can do it from the graphical user interface, and that's very simple. Let me show you how to do that. I can basically decide IPsec. I can take this policy here and decide that this rule, for instance, I put it in the garbage, and then that will remove the encryption. Another way to do it through API, it's to delete, for instance, the rule directly from through an API call. So I have deleted it. Let's verify if that is true. Yes, it has been deleted. So in the IPsec security policy, there is no longer any policy. And what's going on in terms of encryption? I see no longer any ESP traffic. Do I see ICMP traffic? Yeah, see ICMP traffic. What I wanted to, yeah, we've just seen it. And what I wanted to verify is if I'm losing packets. 93 transmitted, 93 received, so I'm not losing any packet. Now let's re-enable the encryption. Here we go. I just recreate this encryption. We no longer see ICMP traffic between my two hosts. However, if we check ESP, hopefully, we see ESP traffic between 72 and 73. So now the encryption is back. In terms of packets, let's verify. We lost some packets during the implementation of the encryption. Okay, so now let's verify how easy it is to encrypt traffic between two new hosts, let's say. So I'm going to ping 10.6.48.70, for instance. This one is, so we see that there is no ESP traffic that corresponds to that ping. Do we see ICMP traffic for that ping? Hopefully, yes. It's rescanning 10.6. Yes, I've just seen it. Yeah, you can see it. It's fast, but we can see it. Okay, so now let's configure the new IPsec rule in this policy. I have to refresh my IPsec security policy because now there is a new one. So it has been recreated, let's say. Here we go. So I'm going to add a new rule. Insert rule after. I will put it in protect strict mode, which means that I'm encrypting the traffic, and if the other guy on the other side of the server is not able to encrypt or decrypt, the packet will be dropped. So source 10.6.48.73, enter 10.6.48.70. If I don't do a typo, that's better. And let's check ICMP traffic. Well, by the way, that means that I can specify that I want to encrypt a specific protocol and not some others. So for instance, if I have a critical application, obviously ICMP is not critical, but if I have a critical application, I can decide to encrypt my critical traffic and leave maybe ICMP in clear. Okay, save. I have to save the policy, and now my ping is still running, but it should be now encrypted. And let's verify if that is the case. ESP. Yes, 7370 ESP. So that's good, everything works. So basically you've seen how easy it is to configure a new rule to encrypt traffic. Maybe I can verify if I have lost packets. 174 transmitted, so I haven't lost any packet during that configuration. So it's very easy to configure the encryption. It's very easy to verify that the traffic is actually encrypted by mirroring the traffic on the uplink. So that's for audit purposes, for instance. It's easy also to verify the traffic before it is encrypted. For instance, if you want to do some troubleshooting. So that means that you don't lose visibility even if you encrypt the traffic. And that is all programmable through API. As you have seen, like I was able to delete my IPsec policy from Postman, and I was able to recreate it very easily. So with that, I stop this demonstration. I hope it was interesting, and don't hesitate to connect with me, olivier.valois, VALLOIS @hpe.com if you want more information. Thank you very much.